Okay, to do a problem like this here, what we need to do is first get access to the data set. And what we're trying to do in chapter 4.1 is look at the relationship between two variables. What we were doing in chapter 3 was looking at summarizing data of one variable. That was what we were doing in terms of mean, median, modes, measures of spread. We were only looking at one variable and the data from that. Here in chapter 4, we're now comparing and summarizing data that are related or we think are related in some way. And this problem is just x and y, so there's no variables in terms of like real world meaning. It's just the question, do we find some relationship between the x variables and the y variables? And that's called linear correlation. Do we find some pattern? This one doesn't look that strong because if we look at the graph, D is the graph of this data here. And so what we want to do to check to see if there's correlation is calculate the correlation coefficient. And you do that, you open up StatCrunch. When you open up StatCrunch, again, the data comes in. And what you want to do is you're going to stat regression, simple linear regression. That's what you're choosing. So that's the process of what we're doing in this chapter, simple linear regression. And we click on those variables and you just run, you compute. That's it. Those are the steps. That's all we have. Now as we go forward in more advanced problems, we start to use this information here. These equations mean something, but right now these are just x and y variables. One thing that does come up is the correlation coefficient. How well are these related? And so if we have a linear relation, right, or a linear correlation, this value will help determine that. So we see it's negative 0.1118, so it's negative 0.112. That's what we're looking at. Here's the graph of that data. You can see it doesn't look like some lines, kind of scattered all over. And so we'll then verify that. I have negative 112 as your correlation coefficient. And so with that then, what you have here, I think it's just rounded to 3. Make sure you're following always the rounding conventions, 3 decimals. That's the answer. And then how do we check to see? We have to compare that number with the critical values here. And you get the critical value. There were 5 data points, so we look here. And so since the absolute value of negative 112 is smaller than this critical value right here, we say we do not have, right? We do not have a linear correlation because the correlation coefficient is smaller than the critical value, the value that statisticians have determined ahead of us or in advance of the critical value that we would have linear correlation for that number of data points. That's it.